Okay, let's get started. So everyone's looking bright and chipper, which is good. Sometimes it's kind of a subdued buzz, but everyone looks wide awake. So today, actually one thing I did not say last time was kind of how the course unfolds. So the first month of the course is actually a review of the C++ concepts that you learned in CS102, but also an embellishment on them. So for example, today we're going to be going over input and output streams, which are C in and C out. But you're going to learn some additional things about them. For example, you're going to learn about the fact that CN has a failure mode that you can use to detect whether input has been read correctly or not. You're going to learn there are multiple types of output streams. There's an error stream as well as the normal output stream. You're going to learn about a command called printf, which allows you to create formatted output a little more easily than using cout. So the first month is kind of where we're going over concepts you learned in CS102 so that you can come back up to speed, because even though you did some programming in CS130, you've had a 3-month hiatus, plus the really intense programming, it's been maybe 8 months since you did it. So we want to get you re-immersed in those concepts, as well as I said, to explore in greater detail some of the nuances. And then after that first month is when we start getting into the data structures portion of the course, and we talk about those find, insert, delete operations we talked about on Thursday. So today we're going to look at CN, and we're going to be in particular interested in its so-called failure mode, and we're also going to be interested in its EOF function. And then we're going to talk briefly about cout and carr, which are the two output streams. But we're predominantly going to focus on a new command called printf, which allows you to create formatted output. Before we do that, I want to point out that starting today, there are some after-class activities, and they tend to be fairly short. So today, if you look at the lecture notes, they're always listed. So it says during after-class challenge activities. So it's going to be all challenge activities in 16.3. I think there's like either 2 or 3 of them. They're not very long. It just makes you write some simple things in cout. And in fact, if you get some time in lab tomorrow, I'm fine with your doing the challenge activities in lab. They're due generally 2 days after the class in order to force you to rehearse materials. So these are due on Thursday. That's why sometimes the Tuesday ones, if you get a moment, you can certainly do them in lab. I'm fine with that. Okay, so I typically lecture out of the online notes. If you remember from also Thursday, the book gives you kind of the basics, and then the online notes give you some more detailed examples. And what the book doesn't really talk about as much as we would like is the so-called failure mode of CN. So I'm going to skip ahead because I assume that you actually read the book and that you are fairly familiar with CN. But what you may not be so familiar with is how it can fail if the input is bad. So let's say that we're reading from an integer. So here we have a program and we're reading into integers. Okay? And the question is, what happens if we fail to read an integer? So first of all, let's actually do that. So write a very quick program. I'll call it cn.cpp, and I'll include IOStream using namespace std, And I'm doing this because I also want to show you something. So we're just going to read into I and then see out I equals. Okay, a very simple program, right? We're just reading an integer and then we're writing it out. So we'll compile it. Does anyone remember how we compile this program? -O. To name the file, what do we typically name it if the file name is cn.cpp? cn, very good. Okay, so it compiles it. So now we run it. Oh no, it's just sitting there. We must be in an infinite loop. No, we're not. So what's it waiting for? Input. Okay, so oftentimes we prompt for input, and that way the user knows that we want input. In this case, we failed to prompt the user for input. So it appears that it's just sitting there, but it's not. And this is actually a common thing that's going to afflict you early on, is that you're going to get this where we're not prompting you, we're not requiring you to prompt for input, and so you may forget to start entering input. Okay? Sorry, Rachel, I know I'm taking it from you, but it was a good actually thing because other people have that issue. So when cin, it means it's taking console input. So it's wanting input from the console. So I'm going to enter 20, which is a perfectly fine integer, and it works. Okay? So let's see what happens if I now enter a real number, 20.7. Okay, it still worked. What did it seemingly do? Truncate it. Okay, now let's enter Brad. Okay, I equals 0. That's not so good. Okay, let's try Zach. Still not good. Okay, so we're entering something that is not an integer or a number. And so it's not sure what to do with it. And in this case, we're actually not sure whether it's failing. Actually, I'll tell you what it's doing. It is failing. And it is leaving the previous contents in I. So whatever I was before the read, it's still there afterwards. Okay? So let's actually set I equals 10. Okay, so I was equal to 10, and let's rerun it. And it should have, oh, wait a minute. No, it should have been 10. Okay, my Macintosh has not been doing stuff that I expect it to. So it should be saying, not putting anything into I. What we can do is check to see whether the read succeeded. So cin returns true or false. It returns true if the read succeeded. It returns false if the read failed. And it returns false if any portion of the read failed. So let's say that I was reading 2 integers, and the first read succeeded, but the second one failed, it would still return false. So if any part of the read fails, cin returns false. Otherwise, it returns true. And in general, if we don't tell you to expect correct input, then you need to check to see whether the input was correct. If you don't, that is how hackers exploit programs. Okay, the biggest way they exploit programs is that they put input in that the input is not expecting, or that the program is not expecting, and the program naively then tries to process that input, but since it's junk, the hacker can trick the program into doing things it should not do. Okay, so it's very important that you do what is called error checking to verify that the input is correct. So in this situation, we're just reading I. So if the read succeeds, I'm going to go ahead and print out I. Otherwise, for the time being, I'm just going to print out failure. Okay, so if it fails to read the integer correctly, I'm going to print that it fails. In fact, so you can keep seeing the program, I'm going to create a second window, put them side by side so you can kind of see the program, and you can actually see me compile it as well. So there's the program. Okay, so we'll run it, and we'll start out with something nice like 20. It works just fine. Now we'll enter Zach. Oh, come on, that's got to fail. Let's try Otis. Still not failing. Yeah?
In the pre-activity notes, it said that if it fails, you can set it to either 0, the max allowed value of the data type, or it can skip.
That is different. Okay, but they're still failing.
It fails, but it sets I to 0.
That's fine that it's setting I to 0. Okay? What it should be doing, though, is it's returning true. Okay? That is not right. So I'm trying to do, let's see. Did I not save the file? Ah, there we go. Now that would do it. Okay. Perfect. Thank you. That's where it's good to have multiple eyes on things. Okay. Brad, failure. Zach, failure. Good. Okay. You can see it's still early in the morning for me. Okay. So, when you get a failure like that, there's one of the things you could do. You can immediately print an error message and exit. Sometimes we'll tell you to do that in the lab. If you find an erroneous input, exit the program. But generally print an error message because you want the user to know what went wrong. Like, I expected an integer and you gave me this. Okay, normally you echo back whatever the input was. So in this case, you would like to try to echo back what the input was. Okay, so you might not like to say something like something more helpful, which is invalid input, and you'd like to now be able to echo out the input. Except we didn't read it. Okay, so the question is, how can we echo back the input when we were unable to read it in the first place? Well, the first thing you need to know is that just like a copy machine or a printer, CN is now jammed. Okay, so after reading, so we'll put it over here. So after CN fails, it is in a jammed state. Okay, at least that's the analogy I like to use. So just like a printer jams, you can think of CN jamming. Okay, it's choked on the input. Okay, it's like the input is sticking in CN and it can't get out. So you need, just like with a printer jam, you need to clear the jam before you can proceed. The same thing is true here. You have to clear the jam. So the first thing you're going to do to clear the jam is there's a command called clear. Okay, cn.clear, it tells CN all is well. It's like on a printer, after you clear the jam, you push the button to indicate that it's okay to proceed. Okay? But all that it's doing in this case is it's telling CN that all is well, but it actually hasn't cleared that input. So you still have to clear the input, and the way you're going to do that is you should always succeed if you try to read into a string. So I'm declaring a string called bad data, and then I will cin into bad data, and that will clear the jam completely because now we will have the input safely read into that string variable. So it's a two-step process. We first call cin.clear, and then secondly, we read the bad piece of data. Now, if you're familiar with clearing a printer jam, this seems to be the opposite of what you would normally do. Normally, you would first yank the piece of paper out of the printer, and then you would hit the OK button. Okay? Because normally when the printer is jammed, you don't hit OK because the piece of paper is still sitting there. So this is the opposite of what you do with a printer jam, and this is the order in which it must be done. Okay, I'll explain why in a moment. For the moment, let's just see it in action. So what I'm going to do up here is declare a variable bad input. So when it jams, I'm going to call cin.clear, and then I'm going to read the bad input. So now I'm able to print out my error message. The bad input is in bad input. And I'm going to go on to say invalid input, bad input must be an integer. So now I've given it a nice explanatory error message. Okay, and if I now compile that and I run it and I give it Brad, invalid input Brad must be an integer. Okay, so we're happy. Yes?
What if you see in like more than one variable?
So the question is, what if I see in more than one variable? Good question. So let's say I input 10 and then I input Brad. Okay, it prints 10. So the reason is, if you give it too much input, it simply ignores the input that it did not read. So you can give a program too much input, and it will simply take whatever it needs and leave the rest, kind of like leftovers on a plate. Okay?
What if you did C and I and then like another J, and then you called C and
So, okay, what do you want me to do now?
like C and I and a J?
Okay, so if I did cin like this, okay, now it would make the attempt and it would fail. Okay, so if we do it, of course I haven't, whoops. Let's do Brad. Okay, it still says invalid input Brad must be an integer because what it did, it read into I first, and that succeeded. Then it tried to read Brad into J and it failed. So because any part of the read failed, the whole thing returns false, so it still came down here. So the 10 had been consumed. The Brad was what jammed it. So it still ends up printing out the error message, invalid input, Brad must be an integer. Okay? So that is that. Now, again, just to make the point, so if you provide it too much input, it takes what it needs and leaves the rest. If you provide too little input, so right now, I've modified the program, it expects 2. If I just give it 1, it's just going to sit there. It's not in an infinite loop. It's hung up waiting for more input, okay? I saw another question. Did I answer that question? Must have. Okay. Now, I said the order is important, okay? So over here, I have to do it in the order first I clear and then I read the input. Okay, if I tried to do it in this order, does anyone have an idea what, there's a nice, let's try red. Does anyone can hazard a guess as to what happens when I cin right there?
It's still going to fail.
It's still going to fail because it's still jammed. Okay? As long as CN is jammed, it cannot operate. Just like when a printer is jammed, it cannot operate. So you have to give the all clear to CN before it can do anything. It's like an acknowledgement. I know you're jammed, so before I proceed, I must say CN.clear in order to let it know that all is well. So if I try to do it in that order, it's not going to work. Okay? So I can actually try compiling this, and it should work. But if I now enter Brad, you can see invalid input. There's nothing here. Okay? Right here, there's nothing because this CN statement failed. Okay? It put nothing into bad input because the CN was still jammed. Okay? So you are going to, in your first couple labs, you're going to be working with CN and using it in this way to detect erroneous data. And if there is erroneous data, then you'll be expected to print an error message. You can either, as I said, depending on what the lab says, there's generally two options. You either exit with the error message or you print an error message and then you reprompt the user. Generally, it's better to reprompt the user. Okay? So that's the first thing about CN. Second thing about CN that we want to cover today is the EOF. Stands for end of file. Okay? So the EOF function, when you type cn.eof, it returns true or false depending on whether we have reached the end of file. Which means we have exhausted the input.
And that's from console inputs as well.
So, good point. Actually, so let's turn this into a while loop. I want to get rid of the ink, and usually there's a little indicator. There we go. Okay, so I'm going to turn this into a loop now. So instead of, and I'm going to get rid of the J. Okay, so I'm going to say while true, okay, let's go to the end, and it's not styled indented correctly anymore. Here's the thing that I posted on the Piazza site. GG equal G will, GG equal G will, should have indented everything properly. Why did it not? There we go. I thought I said capital G, but I did not. So formatted everything or styled everything in a nice way now. So it was small g, thank you for the person who said make sure it's a capital, equal capital G, and that will cause everything to be nicely indented. Okay, so now we're basically in an infinite loop, which isn't too good. Okay, so I will actually start, I'm still going to compile it. So we enter 10, it works, we enter Brad, uh-oh. So does anyone know what's wrong here? We are clearly in an infinite loop. Very good. So I did clear it, but I forgot to put it back into the right order. So what happened is I tried to read the bad input, but I failed. Then I call clear, so it says, okay, all's well, but I actually never cleared the jam. So when I come back up here, that thing, which is Brad, is still stuck in his gullet. So it tries to read it again, fails again, comes down here. Well, it's jammed, so when it tries to read this, it fails. Now it clears it, prints out this invalid input with an empty string, comes back up to the while true. Since we still haven't cleared it, it's still stuck. So basically, it's just stuck on Brad. It's like a, well, gosh golly. Most of you have never heard a record player that just keeps repeating itself because it's scratched. Maybe a DVD, sometimes even DVDs. What other things? There are other things repeat. If you see a stick caught in a creek, I like hiking, so sometimes you see a stick in a little waterfall and it just is forced into an eddy and the stick can't escape. So if any of those analogies work for you, that's what's happened with Brad. It's stuck. Yes? Okay, because it's just the way C++ is defined. Okay? Think of a printer. On the printer, you can also hit the OK button before you clear the jam. The printer accepts your word for it. It thinks your word is gold, and it will try to run again even with the paper jammed in the printer. Okay, it's the same thing here. Just like the printer can't actually remove that piece of paper when you hit the clear button, same thing. C++ doesn't actually clear out that piece of input when you do clear. Okay, so you have to manually extract it just like the piece of paper. As for why, I don't know why the developers didn't clear it, but my guess is they wanted to give you the opportunity to extract it yourself and do something with it. Okay, so I think they figured it was better that you have the opportunity to do whatever you wanted with it rather than do a default action. Okay, so at any rate, I'm going to fix this by just changing the order. So now I clear the jam, I say clear, and then I actually read the input. And now, when I recompile, at least it should invalid 30 works minus 30.7. Okay, that did not go off so well. Okay, so what happened is it read the minus 30. It read all the way up to what it was the end of the valid input, which was minus 30. It turned out it was not truncating. It turned out that what it was doing was just reading up to the first valid, or to the last valid digit, and then leaving the rest, which was 0.7. And then it said invalid input 0.7. So we'll do the same thing. Let's try 25 Brad with nothing after the Brad. So it read up to the B. So it put 25 into I and left Brad on the input. Then it tried to read Brad and it choked. Okay, so in fact, it turns out that when you're reading a number or an integer, it really expects an integer, not just a number. But we have another problem. We're in an infinite loop. Okay? So one way to get out of this, does anyone know what the kill button is in Unix? The kill sequence? Control C. Write this down. Control C is the kill sequence. So if you hit Control, hit it simultaneously. Well, first depress Control, then hit C, and that will send the Control C character, which Unix represents as a caret, but you can't type caret C. It has to be the Control button, then C. It will kill the program. Okay? Now, How do I give instead EOF? Let's say that I want it to just denote end of file. So I want the program to keep running. I don't want to kill it. I just want to give it the end of file command. Does anyone know how I give it end of file to say that the input is exhausted? Yes.
Not cn.elf.
Nope. So I can't. So if I tried to type C, okay, this is in the input. I want to send.
Sorry,
Yes. Yeah, you're right. Don't worry. I want to send a signal to the C++ program that I'm done entering input. New line will not work. It just thinks that I gave it no input. Okay, it is Control D. So Control D sends an EOF signal to your program. So it tells your program that you're done entering input. So if I hit Control D, oh my gosh, invalid input, I'm in an infinite loop. So that didn't terminate it, nor should it have, because when I did the sent Control D, you'll notice that my program does not in any place check to see whether the input is exhausted. So it keeps banging its head against the wall. It keeps trying to read something into I because I never checked to see whether I actually reached the end of the file. So I have to add something that checks to see whether I reached the end of the file. Okay? So don't write this down just yet because this is not the way you want to do things. And I'm going to show you why. So you could say if cn.eof break. So that looks like it should work, right? If I have reached end of file, then break out of this loop. Should work. Okay? In fact, let's do some summing right now. So I'm going to say int sum equals 0. So I really do want to get out of the loop so I can print the sum. So I'm also going to say sum plus equals I. And at the very end of the loop, I am going to see out sum equals sum. Okay, so I want to actually do something else, which is once the loop is done, I want to print the sum. So I really do want to do something after the input is terminated. I just can't terminate the program with Control C. I really want something to happen. Okay, so I added this if cn.eof break, or you might even say, well, why not just do it this way? Why even write the infinite loop? Just say while, and in this case, as the gentleman suggested, while not cn.eof. Okay, so while we have not reached EOF, let's keep going. Okay? Please don't put this in your notes unless you put a big X next to it to indicate that this will give you much grief and misery, even though I will still see this on exam 1. Okay? And the program will still not work. Let's see, why it does not work. Okay? So, Cn, I'm going to enter a single number 10. Okay, now I'm going to hit Control D to terminate the input. And I get invalid input must be an integer, sum equals 10. Well, wait a minute. Why am I getting, after I sent it the end of file character, why did it attempt another read? Okay, let's do that again. Cn, let's do 10, 20. Now I'm going to hit Control D. Why is there invalid input must be an integer? It's because of the kind of strange nature of the EOF command. Okay, you should write this down. Dr. Plank has this in his notes. So I'll show you where, because it's a very important section of his notes. Okay, at the end of his online notes, he has 4 common CN errors. Number 2 is CN.EOF is not proactive. What it means is that, let's say our input is 10, 20, and I'll just put the EOF marker. Think of there being a little cursor in front of the input, indicating where you are in the input. Just like you have a cursor when I type in over here, see I have a cursor, same idea. So when I read 10, the cursor gets moved to right there. And when I read 20, the cursor gets moved to right there. So the cursor after I read 20 is right there. It is not pointing at EOF. It is before EOF. So what happens when you call CN.EOF at this point, it returns false. That's not what you might expect. You're like, we're at the end of the input. It should return true. But it doesn't. And those are the facts of life. You can't change it. It's going to return false because that little cursor is not actually at EOF. It's before EOF. So what is happening in my little program here is after it read 20, it came back up here and it said, have we reached end of file? And CN said, by gosh, no. Okay? We have not reached EOF. So we went in for a final time and we tried to read into I. And what happened at that point is it moved the cursor and tried to read the EOF signal. And it failed because we exhausted the input. So the CN failed and it went down to the else statement and it tried to clear the input, which was fine, and then it tried to read the bad input, but we were at EOF. It couldn't read anything, so when it tried to read the bad input, which was non-existent, into bad input, nothing got read again. In fact, CN jammed again. You don't know it, but it jammed again, and we end up printing out Cout invalid input. Now we go back up for the 4th time, and it says, by gosh, we're done. You're like, thanks for that. A little late. Horse is out of the barn. Okay, so at any rate, it now exits the loop, and it prints out sum equals 30. But in the meantime, we had this invalid input must be an integer sitting there. Sorry, can't get rid of that. Oh no. The rainbow of death. That probably means that it's stuck forever. Oh, good. Let's do a force quit because, yes, the terminal is not responding. We kind of got that. Okay. So at any rate, don't do this because EOF is reactive, it's not proactive. Okay? So that means that it's always too late in diagnosing EOF. So we're back to the while true statement. Okay? And we are going to make an attempt to read in I. Then, before we do our clear statement, this is important, now you should write it down because you will be using this in Lab 1. Now we're first going to check to see whether the read failed due to EOF. So before we try to clear the jammed input, we're going to see, hey, was it the end of the input, in which case we need to get out of here. Okay? in lab 1, the Moonglow lab, this is the right way to go. So you write an infinite loop. Then you write a CN statement with an if protecting it. So if the input succeeds, you do whatever you need to do. The next thing you do is check if the input has failed. You actually check to make sure whether you have reached end of file. Because if you've reached end of file, it's time to get out of Dodge. And then if you have not reached end of file, that means you had to do something else. In the Moonglow lab, it's actually not an error condition. It means just that you did not receive an integer and you're going to proceed to do some other action. In my program here where I'm summing numbers, it is invalid input. I clear CN, read that bad input to clear the jam, print it out, and continue. Yes?
Could you also do like a CN right before the while loop, and then you don't need that
Yes.
break?
Okay. I'm not going to cover that. I'm not going to cover that. So you know what it's called. It's called a priming read. Okay. There's a name for that, and it's called a priming read. Okay. I'm not going to cover it. It's another approach, and I don't want to confuse. But if you use it, it's good.
I saw it in his notes.
Yep.
So okay.
It's a priming read, and it works too. But I have limited time today, so I'm not going to cover the priming read. I'm going to cover this approach. Okay. Because this is the approach he uses in much of his notes. Okay. So if you read about the priming read in the notes, you know how, feel comfortable using it, go ahead and use it. I'm just not going to cover it. I won't have time today. Okay? So let's just run this program, verify that it works. Okay, so 30, 40, Control D. Oh, give me a break. What did I not, wait, write, compile, run. And I get invalid input. Why am I getting invalid input?
You ran the wrong, or you compiled the wrong program.
Oh, I close. Ah, that's right. So, okay, sometimes when your terminal program is force quit and you hit the previous command, it remembers the wrong history. So it remembers my history all the way back. That was nice. I guess when it crashed, it forgot my most recent history. Thank you. 30, 40. There we go. Sum equals 70. Okay? Questiones? We good? Okay, one last thing about CN, and it's the redirect, and then we'll get to printf. So we said we covered the failure mode, we covered EOF. There's one final thing, it's called the redirect operator, which is the less than. Okay? You will see it in his notes. Except I don't want to have to find it. Ah, there we go. Right here. So sometimes you redirect input so that instead of reading from the console, so normally when I do CN, I'm reading from the console. So when here, it's expecting me to input at the console. Okay? But I can instead put my input into a text file. So here I have 10, 20, 30, 40. And instead, I can say, instead of reading from the console, why don't you take what is called standard in and read it from input.text. So basically, CN, there is a stream, and that stream is called standard in. So normally, standard in is the console. But you can tell your program to look elsewhere. So instead of looking at the console, you can tell it to look at a file and read from that file for standard in. So in order to do that, you use the less than operator at the command line. So right here, I'm saying, hey, don't look to the console for standard in, look to input.txt. And sure enough, it reads 10, 20, 30, 40, adds them together and gives me 100. So when you see this less than, okay, what is going on is that it is saying, instead of reading from the console, instead, when you do a cin statement, please read instead from input.txt. So the less than, in this case, is a redirect operator. So we say that it is redirecting from the console to a file. And you'll do that a fair amount as well in your labs. So questions about cin? Okay. So in that case, let us proceed to cout. And cout, you should remember, is the way you print stuff. And the book went over how to do formatted output, and we did that in 102. So I'm going to presume you know how to create formatted output using cout. And the challenge activities will give you a little more practice doing formatted output using cout. So I want to talk about some of the embellishments. So first of all, there is a third. Wow. And now we have crashed here as well. How nice. Okay. That means I can only really go back here, go to output, cout, and cair. So cout is what you use to produce normal output. Cair stands for standard error and is what you typically use for writing error messages. So here, I'm writing this to cout, I'm writing this to cair, and by default, both go to the console. So we call each of these a stream. So you'll hear input stream, output stream. It's why you include IO stream. Okay, so we talk about streams of input, streams of output. Think of a stream with running water. Okay, so cout and cair are two different streams. Well, in this case, they both come into the console river. Okay, so it's like they merge, and anything in the cout and anything in the cair, they both go into the console river. But it is actually possible to redirect them so they go to separate files. Okay, so as an example, let's do a simple program. Err.cpp. And we'll start out with cout output stream and cair error stream. Okay, so first of all, we'll just compile this program and show you that it goes, both streams go to console. Okay, now I'm going to redirect using the greater than. So I am now redirecting the standard output to output.txt. Okay, you may not have seen the more command. The more command lists the contents of a file and will just give you a page at a time. And you notice I'm at the end here, I type Q to get out of it. So it's like a mini VI, actually. So more just dumps the contents of a file to the screen. So you can see that in this case, I redirected my standard output to output.txt. The C error continued to go to the console, and when I listed the contents of output.txt, it went to output string. So it is possible to separate the two streams. Okay? Now, this is what I forgot to look up this morning and meant to. So you're going to see me possibly mess this up. Yep. Okay, so now I have redirected the error stream. So I said error greater than to output.txt. I said 2 greater than, so there was no separation here. I could have said it like this to make it very clear. So this sent the error stream, this 2 greater than sent the error stream to error.txt. C++ numbers its streams. I believe standard in is 0, standard out is 1, standard error is 2. So this is just saying take the second stream, redirect it to error.txt. So it is possible to divide those streams up, which is what you often do. You might send, the common thing would be to send the correct output to a file, and then you would keep on the console, because you want the operator to see immediately any error messages. You would normally leave C error printing to the console because you want the operator of the program to immediately see whenever an error occurs. So the bottom line here is that there is 2 different output streams, C out and C error. You write your valid output to C out, you write your invalid output and error messages to C error. Normally they both go to the same place, which is the console, but if you want, you can redirect them into different files using the greater than operator. Okay, and just like the less than operator, the greater than operator is called a redirect. It's saying don't print to the console, instead print to this file instead. Okay? Any questions about that? Yes?
And if you were going to do multiple things, like read from a file and redirect out to a file, you just list them like normal?
Yes, so if I was reading from a file, so I could have said my cin program will read from input.txt, output to output.txt. Okay, so that's saying the less than says redirect standard in to input.txt, send my output to output.txt. Now I won't see anything, but if I say more output.txt, there's all that standard out stuff. Okay, yes? It would still be first. Is that what you're, pardon? Oh, no, you can't. So C++ always assigns these numbers. 1 goes always to C out, 2 always goes to C error, 0 always goes to, okay, yeah, you can't. They're fixed. So anytime you want to redirect into C error, you'll use 2 greater than. You could say 1 greater than for C out, but it's irrelevant. It will assume that's what you want. Okay. Yes. It can be any way you want. Okay. So my recommendation is that you put the redirect operators first and the command line arguments second, but it's just I don't really care. Okay, it's supposed to be smart enough to figure it out. Okay, the less than and greater than are supposed to be reserved operator symbols indicating that we're redirecting, and so it should not confuse it. But for humans who do get confused, it's better to put one first and the second. Either put all the command line arguments first and then put all your redirects, or put your redirects first and then all your command line arguments. Other questions? Okay. Final thing for today is printf, which you have not seen before, but it is another way to do formatted output. And printf was used with the original language C. So C++ is evolved from C. So in C, the output command was printf, not cout. And later in the course, we won't care whether you use printf or cout. It is whatever is most convenient. Early in the course, we will specifically tell you either to use cout or printf because we want you to get practice with both. So printf stands for print formatted output. And it actually tends to be easier to produce formatted output using printf rather than cout. So here's a very simple one with no variables being printed. So you see everything is in parentheses, quotes, and it looks just like cout except that printf is a function, so we give the string to be printed to the function. So that's really simple. Okay? Before I forget, if you're going to use printf, you have to include C standard I/O in your program. So if you're going to be outputting using printf, you have to say C standard I/O because printf was part of the C library. So C standard I/O is the C library. And we're going to do something a little more interesting. We're going to say I equals 10, printf I equals %d. So what the %d says is I want to print a variable. That variable is an integer. How do I know that? %d is interpreted by printf as an integer. More recently, they have changed it to the more mnemonic %i. So %i also works and means integer. So either %d or %i works, but you will see Dr. Planck use %d because that was the original. Okay, I don't care whether you use %d or %i. So you are telling printf that it is printing out a integer with %d. So if I compile error and run it, we get I equals 10. Okay? Simple enough. So let's say I want to print two things. I also want to print the string name. So I can print a string with the format specifier %s. So whenever you want to print a variable, you use what is called a format specifier, or a format, oh, that's right, it's busted. You use a format directive. Okay, so %d or %i is an integer. %s is a string. %f says you're printing a floating point number, and that can be either a float or a double, doesn't matter. Those are, oh, and %c says you're printing a char. Those are the big ones that you use. %d or I, %s, %f, and %c. Okay, at least for the time being, those are the ones you need to know. Now, let's actually do that. So whenever you want to print, you have to tell a variable, you have to tell C++ how to interpret the variable's type. So C out is nice. You never specify the variable's type. C out figures it out. Printf isn't so kind. It forces you to provide the correct type. In fact, before we print out the string, let's give it an incorrect type. Let's tell C++ that I is a string, which we know it's not. Okay, and let's see what happens when we try to run it. Oops, the compiler is smart enough to realize that we gave it an invalid format, that it's expecting type string, which you see is char star. I'll talk about that in a moment, but the argument has type int, and it's suggesting that we need to use %d. How nice. Okay, so let's go back and use %d. And let's also print out a string. So we'll say name equals %s. Okay, don't write this down yet because there's going to be something bad. Error. Okay, with the %s in the name. Did you mean to call the C_string method? Here's the problem. Printf cannot, gosh darn it, it's so nice when I have the thing. Printf cannot print C++ style strings. Okay? To print them, you must convert them to C style strings. The way you do that, the way you get a C style string is with the .c_. Okay, so to get a C style string, use .cstring. Okay, what that does is it extracts a C style string and returns it. Okay, what that is right now, don't worry. Just do it. Okay, so in order to print out name, I actually have to say C underscore like that. Okay, that will print out now a C style string, which is what we want. So in fact, if I go over here, I know I'm getting overlap now. But if I compile it, it's now happy, and it does what I want. Okay? A couple more things and we're done. First of all, you may remember that sometimes you want to print fields with a certain width. So maybe, no matter what, we want the integer to be printed in a field 5 characters wide. In that case, we put a number before the type. So here we say we want I in a field 5 characters wide, and I'm putting the name in a field 10 characters wide. There is still a space right here. So even though I said 5 characters wide, it's going to end up looking 6 characters wide because there is a space right there. Okay? So if I run it and compile it, it now, what did it do? What kind of justification? Right justification. So it used right justification. Okay, that's not always what we want. We sometimes want left justification. If you want left justification, you put a minus sign in front. So the minus sign, sorry, you have to write it down. The minus sign indicates left justification. So if I compile it and run it, I equals 10 is now left justified. So the minus sign left justifies. You might ask, what centers it? You do. Pain in the neck. If it were Java, Java did introduce a format specifier for centering. So if you've used Java before, Java does allow you to specify a centering attribute, not C++. One more thing, and you're not over yet, it's 10:54. Let's say that we were printing out a floating point number. So let's do a double, x equals 3.9, whole bunch of stuff. So we want to print it in a field, but we only want to print the first two digits. The first two fractional digits. The way to do that is point to f. So the 0.2 says we want 2 digits after the decimal point. You don't have to worry about telling it to use fixed mode like you would with cout. It knows automatically that that's what you want to do. So if we run it, voila, 3.95, it is rounding. So you can see it is rounding, not truncating. Okay, last thing. Let's say we wanted it in a field that was 8 characters wide. What we're saying now with 8.2f, this is the last thing, so 8.2f, it says print it in a field 8 characters wide. Okay, there's 8 characters. 2 of them will be the decimal digits. 1 of them will be the dot. So you're actually leaving 5 for the number. Now, see if you can remember, last thing. What happens if I try to print out 100,000.82? It doesn't fit. What's going to happen? Is it going to truncate? No. So it's a minimum width. It means that we're guaranteed the output will be 8 characters wide. If the value requires more than 8 characters, it will get it. So while the decimal digit will always be truncated to however many digits you say, if this field is not big enough to contain the value, whether it's a string, an integer, or a floating point number, C++ will print the entire value. Okay? So that is your introduction to printf. You will not be using it in the first couple labs, then you will use it in the next couple labs, then you'll get to do what you want. Remember, there is challenge questions, so don't forget to do them. And I will see you Thursday. One second.
Sure.